Okay, in lesson 17 today, we're going to do a proof of the Pythagorean Theorem. Depending on who you had last year, we may or may not have done a proof with you last year, but this is a different proof. And then we are also going to have some things for proving that triangles are similar. We already have 4 alphabet soup things for congruent triangles. These will be alphabet soup ways for ones that have the same shape, but one may be an enlargement of the other one. So first, proving our Pythagorean theorem. Everybody see a right triangle up there, the big outside one. So that means we want to show for that right triangle a squared plus b squared equals c squared. So what we are going to do is to separately draw the 3 little triangles. So first you see the small one from the right with the x on as a leg and an a as the hypotenuse. Then you see where I've taken the one on the left and I've tilted that so it's turned the same way as that first little one. So b is the hypotenuse and y is the long leg. And then I have the whole thing, but I had to kind of flip that and turn that. So the short leg is on the bottom, and that's A. The long leg that's vertical is B, and the hypotenuse is C. Then I'm going to start writing down things that I know about these similar triangles. I know that these are similar. They all have a 90-degree angle. And then, let's see, this one and this one, that's actually the same angle. And then this, see, I've lost my spot here. This one and this one are the same angle. And let's see, those share. So if I go through, I can get that they all have the same angle measures, which means that they have to be the same shape. So I'm going to set up my ratios now. Remember, similar triangles have proportionate sides, not congruent sides. So first I am going to take the 2 triangles that have an A in them, and I'm going to write proportional sides, as many of them as I know, for those 2 triangles. So I am going to say A over X is equal to C over A. Everybody good with that? Okay, then I am going to take the 2 triangles that both have B in them and do the same thing with those sides. So I'm going to say Y over B equals B over C, just setting up the ratios of those corresponding sides. Then I am going to take cross products for each of those proportions. So A squared is going to be equal to C times X. And B squared is going to be equal to C times Y. So I'm going to remember, I want to show A squared plus B squared is C squared. So I am going to write down A squared plus B squared is something. Well, I know that A squared is CX and I know that B squared is CY. That means I can factor the C out, and I have C times X plus Y. I want A squared plus B squared is C squared. I have one of the C's. So I wonder, well, what's X plus Y? If I can figure out that it has to be C, I'm home free. So I'm going to go back to my original picture up here, and I am going to look at that, and I am going to say, oh, if I take X plus Y, that's just as long as C, right? So X plus Y is equal to C. So then I can put that in for that x plus y, and I have c times c, which is c squared, so a squared plus b squared equals c squared. Let me just prove it that way. For a formula list, we're going to have some things that look similar. Is there an SSS for congruent triangles? Yes, there's not an AAA, there is an SSS. And so what that means, oops, it's got that line in there I didn't really mean to draw. So SSS means you know, or you can prove A over D equals B over E equals C over F. It does not mean the sides are the same length. It means all three sides set up the same proportion when you set up the similar triangles. If you know that, then the triangles are similar. All you need to write in your proof is SSS, because on the side where you're doing your statement, you'll have the similar symbol and not the congruent symbol. Just a single little swiggle means similar. What about SAS? Do we have that for congruent triangles? Yes. We also have it for similar triangles, but it's a little bit different again. It means you need to be able to show two sets of sides are in proportion, so A over D equals B over E, and you need to show that the angle between those is congruent. So we took the A over the D, those were corresponding sides, and we took the B over the E, those were corresponding sides. So we had to be talking about the angle that was in between there if we want to use SAS. And again, you don't have to write similarity in there, just SAS, but your statement on the left side of your two-column proof will have the similar thing. What about AAA? Does that work for congruent? No, because if the angles are all the same, we could have the different size triangles like we have here. So there is no AAA for congruent. So this one says we have one set of angles here that match, we have another set of angles here that match, we have a third set that match. That's enough to say that the angles are similar. And then we have some examples to run through. So some of your homework problems will just be, are they similar or not, and what's the reason? Others will be a full-blown proof. So first ones that are just, are they or aren't they, and what's the reason? So for these, as we are trying to set this up and figure out what's going on, to figure out the corresponding sides, well, we don't really need to do that on this one. For this one, I've got one set of angles, a second set of angles, and a third set of angles. So everybody, thumbs up similar, thumbs down if it's not. So everybody's got a thumb up. And Trayton, what's the reason? So this one is yes, because we have all three sets of angles. So that would be all you would have to write on that one. Actually, if the book does not already give it to you, you also have to write the statement. So triangle, pick one of them, X, Y, Z, do the similar sign, and then the other triangle. X and the left one corresponds to which angle on the right, everybody? R. X has two tick marks. Which other one has two tick marks? H. Y has one tick mark. What has one tick mark in the other one? I. and that leaves J. So if the book already has, is triangle XYZ similar to triangle HIJ, you don't have to write that. If the book just says determine if they're similar or not, you do have to write which way it matches up. Does that make sense? Okay, this one. What do we think here? This one's actually a little bit tricky. So for this one, well, let's see, I'm looking at that, and so I know that B and F match up. So that means the sides across from them have to be corresponding sides, but I don't know numbers on those to set up a proportion. So I'm going to say, oh, well, it looks like I can just kind of flip 12 over 7. Is that the same as 14 over 6? Are those the same fraction? They're both reduced completely. They don't have the same numbers in there. Oh, that didn't work. Does that mean they're not similar? Is there another way I could try to match these things up? Riley?
So the other one match would be 7 over 14 and 56 over 5.
Maybe they match up like this. Because similar, you can twist them anyway, you can flip them over. So you have to think about the other possibilities. And is it true that 6 over 12 is 7 over 14? So yes, but now we have to write the similarity statement because we don't already have it. So we would say triangle ABC is similar to triangle, and I know the B and the F in the middle have to match up because they were marked. If the 12 and the 6 are corresponding sides, then I have to go to the angles across from them. A and E have to match up. And that leaves D. That's what you've got to be a little bit careful about it means. One more of this kind of thing, and then we'll do a proof and that's it. So, 6, 15, 12. What do you guys think? How many think that's going to be similar as you look at that? Thumbs up, thumbs down if you don't think it's similar. So I'm seeing quite a few thumbs up. So if I do my fractions, if I do 6 over, everybody, which side are you matching up with that? And 12 over and 15 over must be 5. Are those all equal?
Yes.
Because, whoops, they all equal 3. So we don't already have the similarity statement. So LMN is similar to the other triangle. L was across from the 12, and we said 12 corresponded to the 4, so we have to have an S in the same spot as the L. The M was across from the 15, that matched up with the 5, which is across from U, and that leaves T. And so what was our reason on this? I need to go back on the other one. I don't think I wrote the reason. What did we do here, everybody? We did all 3 sets of sides were similar. If I go back to this one, we have how many sets of sides? And was the angle in between those sides? So this one, the triangles were similar by SAS. Okay, one proof. So we're given AC and DF are parallel. So AC is parallel to DF, and that is given. I am also given that BC is parallel to EF. So that means these two. So for just a moment, I'm going to think about those two lines that I just marked with blue that are parallel. And I've redrawn those down here. And now I'm redrawing this bottom of the triangles, but I'm extending those parallel sides a little bit farther. So right here is where I had point A, and here's where I had point D. So far, so good? Okay, if I turn that just a little bit, so if I turn that more a direction that you're kind of used to looking at it, let's see, if I do it maybe that way. I had two angles that were inside my triangle here. I have one right here. Oops. And I have one angle right here and one angle right there. And so on this picture, here's that angle and that angle. With parallel lines, is there any reason why those angles have to be congruent? Who can tell me, for those parallel lines in that bottom picture, why are those two that I just marked ones that have to be congruent? Bill? Alternate interior would have both of them in between the parallel lines. So we're getting close here. L? They are corresponding angles. So I don't really put that on my paper. That's just kind of my scratch work, or you guys can turn your book, your problem set paper, any which way you want to see what matches up. A little bit harder for me to do that on the whole thing here. So I'm going to say as my next reason that angle A, and I only have one angle at A, so I only need one letter, has to be congruent to an angle at D, but at D I have both this acute one and this obtuse one. And to say I'm only talking about the acute one, I have to say FDE. And that reason is corresponding angles. Okay, we've done the hard part actually because we figured out how that works. So then if I go over to my other angles here, if I go to these angles, congruent or not congruent, thumbs up, thumbs down. Same reason, but for the other set of parallel lines. So then we can say angle B, and it only needs one letter, is congruent to angle, but we need three letters for the other one, FED. And that is also corresponding angles. So now I have two sets of angles. When you have two sets of angles, what else do we know? If we have two sets of angles, Brent, what do you think we know once we know two sets of angles match up for two triangles? We know that the third set of angles also has to match up because angle, angle implies angle, angle, angle. So I just need to look at my picture and figure out what my other angles are. Oh, C and F, and there's only one angle at each of those, so I only need one letter. So angle C is congruent to angle F. So now for my pictures, I have all three sets of angles. Is that enough to say the triangles are similar? By AAA, so ABC congruent to DEF. So it matches what the book said for me to prove. And my reason is AAA, and I just wrote this wrong. Who knows the mistake I need to fix? What did I just write that's a little bit wrong in there? Sophia? I wrote the congruent symbol, and this needed to be the similar symbol, because they aren't the same size and shape.